just we are in myself, so thanks everyone for coming. So I will just present Panda, which is a platform for network data analytics, but keep in mind just data analytics and also platform. So just a few words. So what I like really is innovation, so it's doing the right stuff at the right time, but also DevOps, because at the moment tech is really good. There's no issue with tech, there's just issue with people, so that's why I like DevOps. So just to give you a few context about the project, so you will see that virtualization, automation, and the orchestration have made real-time service provisioning possible. There's a lot of open source big data technologies at the moment. I will speak later on what they are. And there's a lot of big change in the network space. That's why Panda is really network-oriented, but I will show you some use case which is not fully network. So what we have seen so far, and what explains Panda at all, is that we've seen siloed analytics pipelines. And the issue is that once you implement a data pipeline, and by using dedicated technology, then you are putting constraint on your pipeline, and so it is not really optimal, and you are duplicating effort. So that's what we define Panda, and why we want to achieve a really good big data platform. So we do not invent a lot of stuff. I will just present you some key aspects of the platform. But basically, so this is a Linux Foundation open source project. Why Panda? So really, we really want to make all the big data space really easy for you to use. And I will give you a live demo about deploying some Spark streaming application. And so what we want to achieve really is to remove the complexity of working with big data technologies. And if you want to have a quick look, so there is a lot of technologies on the big data space. So, and you've got some open source distribution of Hadoop, like Hortonworks, which is fully open source, but there is also Cloudera distribution, Mapper. But you can also go the other side with Splunk, which is not open source at all. So we are right in the middle. So just to illustrate one thing, if you want to just keep one takeaway of this presentation, is Panda is about the platform. So do not spend any time on building a platform for doing big data stuff. Just be focused on your use case and on the application. So because you will waste a lot of time of fine-tuning your Hadoop cluster, making analysis, etc. So really do not care about the platform. So here is just a short view about what is Panda. So this is the platform is just in the middle. So on the left hand side, so you've got how to integrate with the platform. So we just use Kafka, a well-known database technology, which is the better one at the moment, in order to be able to push data to Panda. So it's quite easy to use. We are providing as part of the project all the producer, the sample code, and the plugin to connect to the platform. So you can use Logstash. We've got a plugin for Logstash. We've got a plugin for OpenDaylight, and we've got all sample code in PHP, Python, and Java. So, but it's just about using the Kafka API with the Agro encapsulation. And then once you've got your data in the platform, you can either consume them in real time directly from Kafka, or you can build a near-time application based on Spark streaming or Spark batch processing, etc. So what we provide at the moment, so we are on the release 3.4. As part of this release, so we are providing all the the installation to build your platform on top of OpenStack or on bare metal. So this is based on it template. So in less than 1 hour, you can have your platform ready to use. It's also possible to bootstrap the platform on Amazon. As I say, we've got plugins for Logstash, OpenDMP, and a lot more. And so, as mentioned, so you must be focused on the right side, because this is where the value is. Once you've got all the data pushed to a cluster, then you need to build the apps that really extract the value of the data. And so we are already providing some sample applications, such as fault analytics, and not more, but just maybe I want to spend more time on all the texts that are inside Panda. So we are bringing all together using either it template or CloudFormation template for Amazon. We are using SaltStack in order to orchestrate all this stack. And so one benefit of Panda is for every data you push inside the platform, this is automatically stored, well stored in HDFS. So do not care about the data, we will manage it. So we are using Goblin in order to store that. And then after that, you can deploy any application on top of Panda. And what we've built so far is we've simplified this process. We provide some sample code in order to help you building streaming application, for example, and deploying it to Panda is quite easy. We just build a component, you post your application, it is automatically deployed on the platform. You do not care about how to configure yarn, etc. Everything is managed by the platform, as I said. And so just a few words about the console, after I will do the demo. So we provide a console in order to make available all the relevant information and everything you need for using Panda. So this is a kind of dashboard that shows you that all the components are fully working. And it gives you also all the statistics and all the links you need to know. So what we provide also is that, so you've got a set of software available, but we provide also all the operational UI to manage everything within the system. So as for example, for Kafka, if you want to manage it, we are using a Kafka Manager. So in order to create topics, set the replication factor, or set the partition, etc. So everything is available through the UI. For the Hadoop part, so you can access to the Cloudera Manager. If you want to start, because you are putting a lot of data within Panda, if you want to start some investigation, we include Jupyter. Jupyter is a notebook in order to start working in an iterative mode with the data. So in order to play with all the data sets and start building something. And after, so you've got the links for Grafana, OpenTSDB, Impala, all the stuff. So rather than spending time on the slide, I will show you a live demo if this is back. So everything is in GitHub. So if you go to github.com/Panda project, you will find 25 repository, which consists of so you have everything from the it template to the sample application. So for the example, so I use it template. So yesterday I bootstrap a platform. So you've got okay, so you can see that. So you've got a simple CLI with some parameters in order to bootstrap a cluster. So you've got a lot of steps. So in 40 minutes, I've got a ready-to-go big data platform. So just to show you. So on the Horizon UI, so here what it looks like. So when we build the platform on top of OpenStack, so we build a dedicated environment for Panda. So it consists of a bastion, a dedicated network, and a set of VM. So everything is automatically created. So as I said, you do not care about the platform. We manage that. So this is the real Panda console. So just to give you some insight, so on the metrics part, what we've built, so we've built a platform testing component which grab all the metrics for all the components in order to ensure that they are working and expose all the information you need. So you've got all the information for edge base, for example. You've got all the information for Impala, Uzi, etc., and you've got also all the stats for all the brokers available in this cluster. So this is quite useful. Just to show you, so here for the demo, I've just created a topic, and so you will see that there is some data coming over it. And as I mentioned, so here's the U service, which is part of CDH. This is a way to browse the HDFS. So everything is stored as a data set. So any data push to Kafka goes over HDFS through Goblin and is sorted by source. So we've got a little, we do not put any constraint on the data pipeline as said, so we just put an network encapsulation in order to specify a little platform schema, which is just about defining a source in order to know where the data is coming from, a timestamp, a host, and then the raw data. So the raw data can contain whatever you want. This is where you will put all your relevant data for the metrics there. So here's an example. So I've got a collect this source, and so it is sorted also by date. So just to give you some information about the demo. So I just have a little Python script that will push data, so random data, to a Kafka topic. So this is the avro.kso.metrics. So just to show you that with just 10 lines of Python, you can push data to Kafka, to Panda. So to Kafka, you just need to use the avro schema, and then put your raw data within the message. So just to show you that the avro schema is quite simple. It says timestamp, source, host, IP, and raw data. So I will push data just after. Just let me show you that. So at the moment, so I've got my working cluster. What I will do is I will deploy a streaming application. So I already compiled the sample code available on GitHub, the Spark streaming application will just read information from Kafka and will push it to OpenTSDB, which is a time series database. So I just use a package. So there's a few configuration to set. I call the application FOSDEM demo. Good name. It's creating. Okay. So now the application is available on top of the cluster. I can run it. And just to show you that now I can produce data to the cluster. And if I go to OpenTSDB, okay, so I've got my data that are coming over. Yeah, you can see that I've got some points. So just to show you, so this is a real-time application. So basically, it was easy to produce data to Panda, to deploy the application, which just get the data from Kafka and push it to OpenTSDB. So OpenTSDB is a well-known time series database. So most of the time, all the data are based on timestamp. So especially on the network side. So that's why we used to do this kind of demo. So just to show you that it's quite easy to use and simple. So I show you that, so this was backup slide in case we lost the network. So there is bare metal and OpenStack deployment based on its template. You can also deploy on AWS if you want. So within the console, all the platform testing. So the data ingestion is quite easy to do, just with a simple Python code. So we've got also ODL plugin and Logstash. So Logstash is just a matter of configuration. On the data storage part, so I show you that with Goblin everything is stored in the HDFS, but you can use also HBase as part of the platform. The application management is made simple. You just deploy package and it is automatically deployed for within the Hadoop cluster. And then after you've got all the time series and Impala interface available. We use also Impala because this is you can easily connect to Tableau, which is a well-known BI tool. And so just behind that, so we've got at the moment the Cloudera distribution of Hadoop. So and then you've got all the management UI behind that. So now I've just run through the platform. So you see that this is everything is available, and so we apply it first on NFV in order to really get more analytics on top of the network. So the first use case built on top of that were the service analysis and the service impact analysis. And we've done also with MoveSoft, so we integrate MoveSoft in order to provide some fault tolerance on top of an infrastructure. We also apply Panda for IoT and smart cities, for example. This is what we've done so far in Paris. So this is good because this was a data-driven approach, and so we put a lot of sensors within so place destination, which is a big place where we've got a lot of traffic, and the city wants to get events from all the work that they will happen. They will close all the roads that come to the place in order to ensure that there is less pollution, etc., etc. So we put quality sensor. We get data from the device available in the place through the Wi-Fi, the wireless connection. We are able also to integrate some video analytics solution in order to identify the flows. So once you've got the infrastructure, you can build application on top of that. So we are able to identify the different flows happening on the vehicle flows for each road. So then in case of the close one, we identify the impact, so we are able also to correlate the noise with the vehicle. We are able also to identify the density of the pedestrian per section. And also, we are in France, we can do more analytics regarding the noise and correlate that with strikes, because we are used to strikes in France. So as you see, there's a lot of spikes here, and this was, so there's some spike, and we can identify that this was when there are strikes in France, so a lot of spike. Also, as you see, we've talked a lot about OpenDaylight and BGP, so we've done some work on top of that. Maybe what I can do is I can show you a short video about the work done on So this is so what we've done so far. So we've put all the prefix within Panda. As Gilles demonstrated just later on, just so extracting everything from OpenDaylight and putting that into Panda. So we've got all the data. So this is currently, I would say, in development, but we will soon demonstrate it on the Cisco Live Berlin. So you will see that all the BGP events are stored automatically in HDFS. And then after that, so you can run so BGP application on top of Panda. So this is a video, this is good because this is working faster than a live demo. So we can launch multiple instances of an application, and then after, so we've done some data exploration using Jupyter. So this is a way to show you how the Jupyter works. So you can do some iteration on top of all the data sets and start doing some visualization. And so, here you can have a network topology graph based on all those BGP data. And after, you are free to spend more time on the application and on the visualization, which is the key part of all the big data space. And so you can look at all the prefix, you can sort them per AS. And after, just for the fun, so it will be after you are free to do nice visualization on top of all those big data. So this is, but keep in mind also that Panda is about big data. So you need really to have a huge data set or a real big stream of data coming to the platform. Otherwise, this is not about big data. So this is just a nice example. Okay, so we are building an ecosystem around Panda in order to, so we are a small team at the moment on the core development, but we are working with a lot of SP companies and in order to build this ecosystem, and also with third party. So just to mention that, so we are working with the Linux Foundation, so we are working with Moog, especially for the fault analysis in the network, with Topple, with Strings. We are working also with Open Datasoft around all the smart cities topic, with opening all the data. There is also Nginx, ontology, etc. Just to give you a few words about what's coming for the next release, so we plan to do some stuff, especially the big stuff is the data security, which is always good to consider once working with data. We will do also maybe, well, not maybe, we'll do, but all the VMware support for enterprise application. We'll do open source Hadoop. At the moment we are leveraging Cloudera distribution, but we plan to work on the Hadoop upstream in order to have a fully open source platform. And also on the app side, which is key, we will have the so BGP Deep Analytics, which will be showcased at the Cisco Live Berlin. We also have black hole detection, etc. So you still wonder why Panda? So really this is an open source platform, and you've got everything you need for playing with big data. And if you still wonder what is Panda, so go to the website on panda.io. We've put a guide. So I would say read the fucking manual, but this is really, yeah. We put effort on documentation, so we do that. But no, you have a complete guide which explains all the technologies. We try to give you as much insight as possible regarding all the technologies, how to work with Panda, how to integrate, how to produce, how to work on the data instrumentation, how to use all the sample code in order to build your application on top of Panda, etc., etc. And so that now I've got 5 minutes for a question. Yes.
What do you do with PPP?
Sorry?
What are you going to do with PPP?
This is, sorry, what you?
You said you had FAIO PPP on your to-do list?
Yes.
What are you going to do with PPP?
So we can discuss that, but we plan to... oh, okay. So the question is... I was thinking that it was 2 minutes. No. Okay, so the question is, what about VPP? So we are currently... we will integrate VPP, but... this is in the to-do list. We can discuss that just after, but I'm not focused on this part at the moment. But yes.
So my question relates to reporting use Kafka today. Will that be compliant with the BES activity management is right? Do you intend to use that kind of thing, or is it a parallel?
So using Kafka or
One thing called BNF event stream for application reporting to a point function.
I don't know about VS.
Then you know about
Okay, this is stream set or no?
it's essentially a stream, so they're going to sum up the class. I haven't been back with the last one.
Okay, so it's about the question is about using a stream set instead of Kafka. So for Engina, at least, so if you go to the Engina website, you will see that they're using stream set, and we are also putting Panda on the architecture. So I've got a diagram. We can discuss that. Stream set do not replace Kafka, but we can be compatible with this kind of solution. Yes. Sure. Any other question? And I do not have stickers, so. Okay, so thanks for your time. From stream set we push data to Kafka.
Okay, so it could be like some GraphQL stuff coming in or whatever.
Yeah.
Okay, then there's probably, I know that your guys have talked with the AT&T guys already because they actually made the meeting.
Yeah.
So I know there was some conversation around it. I just wondered whether it was making the plans or not.
Yeah. So currently the issue that we are only 5 in the team. Yeah. So we are focused on the core development. We are supporting only 2 customers. We cannot support more. So we've got focus on Verizon and Engina, but we'll also there is also thread with AT&T and